Today we're doing Math 6, Mission 7, Lesson 15, Shapes on the Coordinate Plane. All right, so follow the directions to draw a figure on the coordinate plane. Draw a figure on the coordinate plane with at least 3 of the following properties. 6 vertices, and that's where a vertice is where 2 lines come together. 1 pair of parallel sides, so that's going to look like that, right? At least 1 right angle. A right angle looks like this, remember? And 2 sides with the same length. All right, so if we start with these 2, that should be pretty easy, and then we just have to do 1 more. So I'm just going to start in here, and we're going to go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right, so this is now a right angle, and this is 5, and this is 5. So I've done 1 right angle and 2 sides with the same length, okay? Now I either need 6 vertices or 1 pair of parallel sides. I'm gonna go with the 6 vertices because that sounds fun. So we're gonna go here. So we have 1, 2, 3, 4, 5, 6. Because if I were to connect them all together, right, like that, I would have 1, 2, 3, 4, 5, 6 vertices. All right, so we've done that. Now, is your figure a polygon? Explain how you know. All right, so a polygon is has line segments. Oh, no. I don't know why it's jumping on me. Oh no, and it deleted all of it. Okay, well, a polygon has line segments. And the line segment, so they're not curved lines, a line segment like this. So not curved. The line segments meet at a vertice, right? Only at the end. So end of the line, right? And there are no intersections, they don't cross. And they're 2-dimensional shapes, 2D, right? And they are closed shapes. Okay, so ours is a polygon. Yes, even though it got deleted. What is not a polygon is something that looks like this, right? If we just had this section here, I would say, yes, that's a polygon. But we don't because we have these lines there. And they cross and they're open right here. So that wouldn't work. If I had anything like this, even though it's closed, we have a curved segment, which is not a line segment, right? If we had something like this, that won't work either because it's open, okay? It needs to be a closed shape. All right, let's keep going. Plot the 4 polygons on the coordinate plane. All right, here are the coordinates for the 4 polygons. Plot them on the coordinate plane, connect the points in the order that they are listed, and label each polygon with a letter name. All right, so A is going to be blue. So we have -7. So here's -7 up 4. 1, 2, 3, 4, right there. -8, 5 is going to be there. -8, 6. Remember, X comes first, then Y. X comes first, then Y in a coordinate pair. Then we have -7, 7. 1, 2, 3, 4, 5, 6, 7. Then we have -5, 7. Then we have -5, 5. And we have -7, 4, which is back to the beginning. So we go like this. Boom, 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 boom. Okay, so that is polygon A. let's look at polygon B, and that's going to be green. So we go X first, so over 4, up 3, 1, 2, 3, there's that one. Over 3, up 3. Over 2, up 2. Over 2, up 1. Over 3, up 0. Over 4, up 0. Over 5, up 1. Over 5, up 2. And then over 4, up 3, back to where we started. So here we go. Boom, boom, boom. There, 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 up, back together. That's polygon B. Let's do polygon C. And that's -8, -5. So we go to the left 8 to get -8 and down 5. 1, 2, 3, 4, 5, right there. Then we have -8, 8. So keep going. Then we have -5, -8. And then we have -5, -5. And then we have -8, -5, back to the beginning. So that made a nice square. And that is polygon C. And then polygon D, we're going to do in yellow. And that is -5, 1. So we're going to go to the left 5 and up 1, right there. Then we have -3, -3, 1, 2, 3. So to the left and then down. Then we have -1, so that's to the left. -2, that's down. Then we have 0, 3. So we don't go anywhere left or right, but we do go up 3, right there. Then we have -3, 3. So we go to the left 3 and up 3, right there. And then we have -5, 1, right there. Alrighty. What's that? -5, 1. Oops, I think I did the first one incorrectly. I did -7. I don't know why. Anyway, we start with -5, 1. We end with -5, 1. All right, so -5, 1. Then -3, -3. Then -1, -2. Yep. Then 0, 3. Then -3, 3. And then -5, 1. All right, and this is polygon D. All right. It says, the following diagram shows Andre's route through a maze. He started from the lower right entrance. So here's where he starts. What are the coordinates of the first 2 and the last 2 points in his route? So the first 2 points and the last 2 points right there. So that's what we're looking for. Now, what's cool about this is we have this dot right here in the center, and that is our origin. And remember, an origin is 0, 0. So x is 0 and y is 0. So if that's our origin, that means we can draw a y-axis and an x-axis through that point. And from there, we can use our lines to go out, right? Now, are we going out by 1s, 2s, 3s, 4s? We don't know. We do know, however, that this dot right here is 11, 15. So that means this right here is 11. And we know that this right here is 15. Okay, because x comes first, then y. X first, then y. All right, so how do I get to 11 there? Well, 1, 2, 3, 4, 5.5, that's not 11. So let's go by 2s. 2, 4, 2, 4, 6, 8, 10, and halfway through would be 11. So these go up by 2. Okay. All right, so knowing that, what are our coordinates for the first 2 and last 2 dots? Well, let's go over and see where we get here. So if I go up like this, that's 2, 4, 6, 8, 10, 12. So that's 12, comma, 2, 4, 6, 8, negative 8. 12, negative 8. And then this one is 2, 4, that's 4. And again, negative 8. So that's the first two dots. And the last two dots, they're 2, 4. So negative 4 over, and 2, 4, 6, 8, positive 8. And then we have 2, 4, 6, 8, 10, 12, negative 12, up 2, 4, 6, 8, positive 8. Ooh, did you notice that they're opposites of each other? 12, negative 8, negative 12, 8. 4, negative 8, negative 4, 8. How far did he walk from his starting point to his ending point? Show how you know. Ooh, okay. So we are trying to find the distance that he went all the way like this. Okay, what is our distance here? Okay, so I am going to count off. So this is 2, 4, 6, 8, 10. There's 10. 2, 4, 6, 8, 10. So I'm going to do increments of 10, and then I can count it up easier later. 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. Ooh, don't want it to jump on me. 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. Look at that. So how many dots do I have? I have 1, 2, 3, 4, 5, 6, 7, 8 dots, which means I have 80 units. So how far did he walk? He walked 80 units. Okay. Jada went into the maze and stopped at -7, 2. Plot that point and other points that would lead her out of the maze through the exit on the upper left side. All right, so -7. So I'm going to do hers in blue. -7, so this is 2, 4, 6, there's 7, right? There's 7, but it's -7, 2, up 2 would put her right there. Okay? So we've plotted that point. Now it says, and other points that would lead her out of the maze through the exit. All right. So we're trying to find her way out. So the first one is -7, 2. Then she needs to be able to come to this green line. So we need a dot here. And where does that put her? Well, that's 2, 4. So -4, and then up 2. So -4, 2. Then she can use, I think it's Andre. Yeah, Andre's line from there. So then we do this point, which is -2, 2, 4, 6, 8. -2, 8. And then finally, was I right there? Hold on. Oh, no, -4. I don't know why. I apologize. This should be -4 because we're going up by 2s. -4, so 2, 4, -4, and then up 2, 4, 6, 8. I was right on the 8. I don't know why I messed up on the x-axis. Okay. Well, that's fixed now. And then we need to go to this last dot. So we go over 2, 4, 6, 8, 10, 12. -12, 2, 4, 6, 8. -12, 8. Okay. And if you notice, that's the last two here as well. All right. How far from -7, 2 must she walk to exit the maze? All right. So again, I'm going to get a different color here because I can. I'm going to choose, ooh, let's do like this purple color. All right. So we're going to count again by tens. So she goes 1 there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 1, 2, 3, 4, 5, 6, 7. So we have 10, and then here we have 7. So that is 17. I got 17 units. That's what I got. Okay. So she had to walk 17 units. All right. Create a drawing with a perimeter of 30 units using a continuous path of horizontal and vertical line segments. Okay, so these go up by ones, but every 2 is marked. Okay, so I have to go, I'm just going to start. Let's pick right here. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's another dot. And then 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, but I have to do more than 4. So I'm going to redo this. Let's see. If I want a perimeter, honestly though, if I want a perimeter of 30, so I would need, and I want, let's say 5 lines. No, 6. Let's do 6. If I want 6 lines, 6 divided by 30, that means each line has to be 5, basically. So let's go 1, 2, 3, 4, 5. Right? Then 1, 2, 3, 4, 5. And I'm actually going to go 6. And I'm going to do 1, 2, 3, 4. Let's see. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 28, 24, 25, 26, 27, 28, 29, 30. There we go. And that's 1, 2, 3, 4, 5, 6 lines. So this side is 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 1, 2, 3, 4, 5, 6. This is 1, 2, 3, 4. This is 1, 2, 3, 4. 1, 2, 3, 4, 5. 2. Let's see if that actually adds up to 30. So that's 10. That's 9, 10. So that's 20. 9 plus 1 is 10. That's 30. There we go. So let's look at what these coordinates are, though, right here. Because we're working in coordinates, so let's plot them out. So this would be -1, 0. This would be -1, 1, 2, 3, 4, -4. This one would be -5, -4. This one would be -5, -9. This one would be -7, -9. And this one would be -7, 0. Okay. You can do it however you want. If you want to come up with a different 30, that's fine. Remember, perimeter is the outside length of a shape, okay? Area is the inside, how you fill it, okay? Please review your lesson summary.